A 600-foot, 16,000-ton stealth destroyer worth $7.5 billion is being operated by just 150 sailors. That's fewer people than work at most McDonald's restaurants. Traditional destroyers need 330 crew members to function. So how does a skeleton crew smaller than a high school run the world's most advanced warship? The answer comes down to a radical bet on automation that completely redefines naval warfare. Picture this. While a typical McDonald's restaurant needs 200 employees to serve burgers, the USS Zumwalt operates as the world's largest surface warship with fewer people. We're talking about a floating fortress that stretches 6 football fields in length and weighs 16,000 tons. Yet it runs on a crew of just 158 sailors. To understand how impossible this should be, consider the old Allison-class destroyers. They needed 330 crew members just to keep the lights on and the engines running. That's nearly twice as many people doing jobs that the Zumwalt somehow handles with half the hands. But here's what makes this even more mind-blowing. This isn't just about fewer people doing the same work. The Zumwalt is infinitely more complex than any destroyer that came before it. It packs 78 megawatts of electric power, enough to light up a small city. It carries 80 vertical launch cells for missiles, and its stealth technology makes it appear on radar like a fishing boat instead of a massive warship. So how does this actually work? The secret lies in something the Navy calls a floating microgrid, an all-electric system that fundamentally changes how warships operate. This floating microgrid transforms everything we think we know about naval engineering. Instead of the traditional approach where engines, generators, and propulsion systems all operate separately, the Zumwalt runs on one massive electrical grid that powers absolutely everything on the ship. Picture your home's electrical system, but scaled up to 78 megawatts of raw power. That's enough electricity to supply 30,000 homes. 2 massive gas turbines spin generators that feed this ship-wide network, and from there, electric motors drive the propellers, power the radar systems, charge the weapons, and keep the lights on. But here's where it gets revolutionary. Because everything runs on electricity, the ship's computer systems can automatically allocate power wherever it's needed most. During normal cruising, most of that 78 megawatts goes to propulsion. But when the ship needs to fire its weapons or power up its massive radar arrays, the system instantly shifts electricity from the engines to the combat systems. This is what the Navy calls optimal manning. Instead of having separate teams of sailors monitoring engines, generators, electrical systems, and propulsion controls, you have computers doing most of that work automatically. The sailors who remain focus on the big decisions, while software handles the routine maintenance and monitoring that used to require dozens of specialists. Think of it like the difference between an old factory with hundreds of workers manually operating individual machines versus a modern automated plant where a few technicians oversee computer-controlled systems. The Zumwalt represents that same evolutionary leap for naval warfare. The stealth capabilities work hand in hand with this automation. The ship's strange angular hull design, what engineers call a tumble-home shape, reduces its radar signature to 1/50th the size of a traditional destroyer. On enemy radar screens, this massive warship appears no bigger than a small fishing boat. But maintaining stealth requires precise control of heat signatures, electromagnetic emissions, and acoustic noise. Computers monitor and adjust these factors constantly, tasks that would overwhelm human operators. This automation extends to damage control systems too. Traditional ships rely on sailors running through compartments, manually checking for fires, floods, or equipment failures. The Zumwalt has sensors throughout every section that automatically detect problems and can even begin containment procedures before human crews arrive on scene. The vertical launch system demonstrates this integration perfectly. Those 80 missile cells don't just fire projectiles, they're connected to the ship's power grid, targeting computers and defensive systems through a single network. When the ship identifies a threat, the combat management system can automatically select the appropriate missile, calculate firing solutions, and execute the launch sequence with minimal human input. But here's what makes this setup truly remarkable. Because the ship generates so much electrical power and can redirect it instantly, it's ready for weapons that don't exist yet. Laser defense systems, railguns, and directed energy weapons all require massive amounts of electricity delivered in precise bursts. Traditional ships would need complete redesigns to accommodate these future technologies. The Zumwalt just needs software updates. The crew quarters reflect this philosophy too. With fewer sailors aboard, each person gets more space and better living conditions. But more importantly, the ship has room for additional personnel when needed. If the Zumwalt serves as a fleet command platform, it can embark extra officers and communication specialists without overcrowding. Yet this technological marvel creates an entirely new challenge. With so few people running such a complex system, what happens when something goes wrong and the computers can't fix it? Here's the nightmare scenario that keeps naval engineers awake at night. You're steaming through contested waters at 30 knots when a power grid failure cascades through the ship's electrical systems. Suddenly, the crew of 150 sailors faces problems that would challenge 300 people on a traditional destroyer. This is the dark side of optimal manning that the Navy doesn't advertise in recruitment videos. When automation works, it's magical. When it fails, your skeleton crew becomes dangerously exposed. Consider a basic fire emergency. On older destroyers, you'd have multiple damage control teams stationed throughout the ship, with enough personnel to fight fires, maintain communications, and keep critical systems running simultaneously. The Zumwalt's crew must prioritize: fight the fire or maintain power to the weapon systems, repair the radar or keep the engines running. Every sailor aboard becomes critical because there simply isn't redundancy. On traditional ships, if someone gets injured or overwhelmed, others can step in. Here, each crew member often represents the only person trained on specific automated systems. Lose the wrong sailor at the wrong moment, and entire capabilities disappear. The cross-training requirements are unprecedented. Sailors don't just master their primary specialties anymore. They must understand multiple systems because they might be the only person available when something breaks. An electronics technician might need to assist with damage control. A weapons specialist might need to troubleshoot power distribution problems. But here's what's truly unsettling. The ship's automation makes routine operations so efficient that crews can lose proficiency in manual backup procedures. When systems work perfectly 99% of the time, sailors might go months without practicing emergency protocols. Then crisis hits, and they're expected to perform complex manual operations they rarely use. The psychological pressure is immense. Traditional naval warfare operates on the principle that ships can absorb damage and keep fighting through the collective effort of hundreds of crew members. The Zumwalt bets everything on its stealth capabilities and defensive systems preventing damage in the first place. If something gets through those defenses, the small crew faces overwhelming challenges. Navy leadership insists the automation actually improves safety by reducing human error and providing faster response times to emergencies. Computer systems don't get tired, distracted, or panicked. They monitor thousands of sensors simultaneously and can execute damage control procedures within seconds of detecting problems. The integrated electric propulsion system includes multiple redundancies specifically designed for minimal manning. If one generator fails, the remaining systems automatically reconfigure to maintain power to critical systems. The modular design means damaged sections can be isolated without affecting the entire ship. Sophisticated fire suppression systems can contain blazes automatically while crews focus on other priorities. Still, former destroyer sailors express concerns about the human element. Naval warfare isn't just about technology, it's about adaptability, creativity, and the ability to solve unexpected problems under extreme stress. These qualities emerge from experienced crews working together, not from individual sailors managing computer interfaces. The real test comes during extended deployments, when systems break down far from repair facilities. Traditional ships carry enough specialists to fabricate parts, jury-rig solutions, and maintain operations through improvisation. The Zumwalt's crew excels at managing automated systems, but they might lack the deep technical knowledge needed for creative problem-solving when computers can't provide answers. This creates a fundamental tension in modern naval design. Advanced automation enables incredible capabilities with fewer people, but it also creates single points of failure that didn't exist before. The question isn't whether the technology works, it's whether the human-machine partnership can handle the chaos and unpredictability of actual combat. This creates a fundamental tension in modern naval design, but it also reveals why the Navy spent $24.5 billion on just 3 ships. The Zumwalt program wasn't designed to be a traditional destroyer. It was designed to be a proof of concept for the future of naval warfare. Originally, the Navy planned 32 Zumwalt-class destroyers. The cost per ship would have been manageable, around $3 billion each. But as the program faced budget cuts and technical challenges, those 32 ships became 3. Suddenly, The research and development costs that should have spread across dozens of hulls concentrated into just 3 platforms. $9.3 billion in development costs divided by 3 ships equals over $3 billion per hull before you even start construction. Add the $4.6 billion in actual building costs, and you get the infamous $8 billion price tag that critics love to attack. But here's what those critics miss. The original gun systems that were supposed to make the Zumwalt a shore bombardment platform, they were scrapped in 2018 because each round cost $800,000. Instead of admitting failure, the Navy pivoted to something far more dangerous: hypersonic missiles. Those 80 vertical launch cells can now carry 12 hypersonic missiles in 4 specialized canisters. These aren't just faster versions of existing weapons. Hypersonic missiles travel at more than 5 times the speed of sound and can maneuver unpredictably during flight, making them nearly impossible to intercept. Traditional destroyers can't carry these weapons because they lack the electrical power needed to support the guidance systems and launch sequences. This is where the 78-megawatt power grid justifies its existence. Hypersonic missiles require massive amounts of electricity for their sophisticated targeting computers and flight control systems. The Zumwalt can fire these weapons while maintaining full power to its radar systems, defensive countermeasures, and propulsion. Try that on a traditional destroyer, and you'd have to choose between movement and firepower. The stealth capabilities become crucial here too. A conventional destroyer launching hypersonic missiles becomes a massive target for enemy retaliation. The Zumwalt can fire its weapons while maintaining the radar signature of a fishing boat, making it nearly impossible for enemies to locate the source of the attack. But there's an even bigger revelation about why this program costs so much. The Zumwalt isn't just a destroyer, it's being positioned as a replacement for the Navy's aging command ships. Those massive floating headquarters that coordinate entire battle groups require hundreds of personnel and enormous communication arrays. The Zumwalt's automated systems and extra space from reduced manning mean it can serve dual roles as both a strike platform and a fleet command center. This capability becomes critical when you consider modern naval warfare. Traditional command ships are slow, vulnerable, and obvious targets. Enemy forces can identify command vessels from their size, electronic signatures, and the number of escort ships surrounding them. A Zumwalt serving as a command platform looks identical to any other destroyer on radar, but it packs the computing power and communication systems needed to coordinate complex operations. The psychological impact on enemy forces cannot be understated. Imagine being a hostile naval commander trying to target American fleet assets, only to discover that any destroyer-sized contact might actually be an $8 billion stealth command ship carrying hypersonic missiles. The uncertainty alone changes tactical calculations. Yet this revolutionary approach creates unprecedented risks. Traditional naval doctrine relies on distributed command structures and redundant systems across multiple ships. Concentrating so much capability into single platforms means losing one. Zumwalt represents losing capabilities that would normally be spread across an entire battle group. The sailors aboard these ships understand the pressure. They're not just operating advanced technology, they're proving whether the future of naval warfare works or whether the Navy made a $24 billion mistake. The sailors aboard these ships understand this pressure, and as of January 2026, they're about to face the ultimate test. The USS Lyndon B. Johnson is completing its commissioning process, bringing all 3 Zumwalt-class destroyers into active service for the first time. These aren't experimental platforms anymore. The hypersonic missile integration is complete. The power systems are proven. The automation works. After years of development and criticism, the Navy finally has 3 of the most advanced warships ever built, each operated by crews smaller than most corporate offices. What makes this moment significant isn't just the technology, it's what these ships represent for naval warfare. The Zumwalt program proves that automation can replace mass in military systems. Instead of building dozens of traditionally manned destroyers, the Navy invested in platforms where every sailor multiplies their effectiveness through advanced systems. By 2027, Navy leadership plans to deploy 2 Zumwalts as fleet command ships in the 6th and 7th fleets. These ships will coordinate operations across entire regions while maintaining strike capabilities that traditional command vessels can't match. It's the military equivalent of a Swiss Army knife. Multiple critical functions integrated into a single, highly capable platform. The implications extend far beyond these 3 ships. The lessons learned from optimal manning are already influencing designs for next-generation vessels. Future destroyers, submarines, and even aircraft carriers will incorporate similar automation principles, gradually reducing crew sizes while increasing capabilities. But perhaps the most important lesson isn't about technology at all, it's about adaptation. The Zumwalt program faced massive criticism when its original gun systems failed. Instead of abandoning the platform, the Navy recognized its potential and pivoted to hypersonic missiles. Sometimes, the most expensive mistakes become the most valuable innovations. The 78-megawatt power grid that seemed excessive for traditional weapons now provides exactly the electrical capacity needed for directed energy systems and advanced radar arrays. The extra space from reduced manning accommodates future technologies that haven't been invented yet. The Zumwalt wasn't just designed for today's threats, it was designed to evolve. Those 150 sailors represent more than just efficient manning. They represent a fundamental shift in how humans and machines work together in high-stakes environments. Each crew member must understand multiple systems, make critical decisions with limited backup, and adapt to technologies that didn't exist when they joined the Navy. The real measure of success won't be whether the Zumwalt program was worth $24 billion. It will be whether the principles proven aboard these ships, automation, integration, and optimal manning, define the future of military operations. Early indicators suggest they will. As these three destroyers begin their operational deployments, they carry more than just hypersonic missiles and advanced radar systems. They carry the Navy's bet on a future where small, highly trained crews operate incredibly sophisticated platforms. Whether that future works depends on the 150 sailors who volunteered to find out. The age of massive crews operating simple systems is ending. The age of small crews operating smart systems has begun. And somewhere in the vast expanse of the world's oceans, the USS Zumwalt and her sister ships are proving whether humans and machines can truly work together to redefine naval power. Subscribe to follow how this technological revolution shapes the future of warfare as more nations develop their own automated warships.